Okay, this is the final part of our oligopoly lectures. We are doing the Stackelberg model now with duopoly. So we're back to just two firms, but we're doing an extension of the Cournot model, right? We're still choosing quantities for each firm to maximize their profits, but allowing a sequential setting, right? Where firm one is going to go first, and then firm two reacts to that. You can conceptualize this any way you like, right? If you want to get creative, you could think about there being some corporate espionage going on. However, that has to fit within our framework of how these sequential games work, which is essentially, unless otherwise specified, right, that every player knows the structure of the game. Right? So if we have corporate espionage going on, then firm one that moves first knows that they're being spied upon, right? They know that firm two will react to their output level, and they understand the profit maximization problem of firm two, right? So we're going to use essentially the same setup, constant marginal cost setting, two firms, their total output, gives us the market output, big Q, and a generic linear inverse demand function. Now the sequential setting from the previous chapter, right, that we were looking at, use this sort of idea of saying firm one acts first, and then firm two responds, is able to observe and respond to the choices of firm one, right? So you got different decision nodes down here, and then firm two makes choices, right? This is more complex because firm one isn't just choosing between high and low output. They can choose any level of output they want, right? So the game tree extensive form like this that we played around with in chapter 13 is not going to be particularly useful for this problem itself, but the framework is how we are thinking about this, right? That rather than trying to figure out how firm one would start the game and then figuring out how firm two would continue, we want to think about how firm two, the later players in the game, right, how they would react to any given option that comes to them, right? And then use that to infer backwards, right, through backward induction, what firm one would do at the beginning of the game, given that they know how firm two should respond to them, right? So rather than begin this game or begin this solution by thinking about firm one's profit maximization problem, we're going to begin by thinking about firm two's profit maximization problem, because it is the same thing as before, essentially, right? They now are able to directly observe firm one's output. But if you think about the Cournot setting, they weren't observing the output, but they had to be playing a best response to whatever output the other firm was choosing in the end, right? So their best response function to any particular output by their opponent is going to be the same thing that we get here. We'll derive it just to feel confident about that, but they still have profit determined by the market price, depending on both their output and their opponent's output. Oops. And a cost function, Ch.14, right, or their total profit. And just like before, they aren't controlling the output level of firm one, so that is just a constant in taking their derivative to get marginal revenue and marginal cost. So our marginal revenue is just like before. And that should be equal to, oops, marginal cost is just C. So that is our profit maximizing condition, just like before, right? So imposing this bit of structure that we have here, that's negative b q2 plus a minus b q2 minus b q1 is equal to c, and combining these terms and solving everything, we get that q2 is equal to 1 over 2b times a minus c minus 1/2 of q1. So what have we done? We have, for each of those decision nodes where firm 1 has chosen a quantity q1, we know exactly what the optimal, the best response is for firm 2, right? And since I know that, firm 1 knows that, right? So in the beginning of this game, in the first stage of decision making here, when firm 1 maximizes their profit, because they understand that firm 2 will observe their choice before firm 2 chooses their output level, they know exactly how firm 2 is going to respond. And that's the first mover advantage that firm 1 gets, right? Because they are essentially able to choose firm 2's output by setting their own output. Now, that implies that they have to pick particular values of their own output in order to affect that, but they can take advantage of that in how they maximize their own profit. So the profit function for firm 1 looks the same when we just start drawing it up here, right? There's still price times quantity minus their costs. The difference is they know that quantity isn't just Q1 plus Q2. It's Q1 plus Q2, which is a function of Q1. And they know exactly what that function is. So when they're choosing this Q1, they're also effectively choosing this Q2. So this really is Q1 plus 1 over 2b, a minus c minus 1/2 of Q1. Or, right, just combining these two terms, Q1 minus 1/2 of Q1, that is 1/2 of Q1. Make sure you take a second with the logic of this, right? Firm 2 goes second. They observe firm 1's output, and based on that, they have no control at that point, right? Whatever that output is, they have, and given the market structure and prices in the market, there's going to be a Q2 that maximizes their profit. That actually puts them at a disadvantage in a sense because Q1 knows that they're going to respond to any particular Q1, and so firm 1 can choose their Q1 knowing exactly how that's going to be. So now, what this essentially means, right, is that dP d Q1 is still going to be equal to dP dQ times dQ dP1, or not P, sorry, dQ1, just like it was before, but where before dQ d little q, right, and as it was here, that is just equal to 1, now that's equal to 1/2, right, because firm 1 knows that how firm 2 will respond. So that's going to be equal to negative 1/2 b instead of negative b. All right. So then marginal revenue, right, which is this times Q1 plus P of Q. We'll write it all out. Okay. That is going to be dP dQ1 times Q1 plus P of Q equal to marginal cost, right? This is negative 1/2 BQ1. This is A minus B times this here. Right? P of Q is A minus BQ, and Q is this once we include the fact that we know exactly how firm 2 is going to respond. And so the difference really between the Stackelberg and the Cournot setting is firm 2 has the same best response function as they did in Cournot, but firm 1 is able to include that best response knowing exactly how firm 2 will respond right from the beginning in their profit maximization problem. Okay, so I've got a minus 1/2 BQ1 and a minus 1/2 BQ1, right? So that's going to be just a minus BQ1, which I can add to the other side. And then I'm going to flip the sides. So if you do your algebra carefully, right, that's going to be BQ1 is equal to A minus C. That's this A minus that C. And I've got negative B times 1/2B. So the B's are going to cancel out. So I've got minus 1/2 A minus C, which is 1/2 A minus C. And I divide through by B, so I get Q1 C, or Q1S for Stackelberg is 1/2B A minus C. Bazinga. Pair this up here, you'll note that it is the same outcome as if n is equal to 1, or the monopoly outcome, right? So the Stackelberg leader, firm 1, is going to act by essentially doing what they would do that is optimal for them in this particular setting, and this is mostly because of constant marginal cost. It would be slightly different than the monopoly outcome if they didn't have constant marginal cost. But by choosing the monopoly outcome, right, and then firm 2 will respond to that with Q2S equal to, think about it, we've got 1/2 of 1/2B times A minus C, and 1/2B times A minus C minus that 1/2 times the same term here, right? So that's going to be 1/4B, yeah, times A minus C. So what happens when one firm is able to move first? That firm is going to, because they know how the second firm will respond, they're going to increase their own output, right? And what that's going to do is drive down the optimal output for the follower, right? So the leader produces more and the follower produces less relative to that Cournot outcome, right? Which would be that QC is equal to 1 over 3B A minus C. Right? So the leader produces more than the Cournot and the follower produces less. And then we can also compare QS and QC. Right? This QC is 2/3. I'm going to break these up so that the scalar here is easier to look at. A minus C. And here we're going to have 1/4 times B and 1/2 times B. We add those together and we get 3/4 times 1 over B. So the net effect, right, is that total output is increasing because as firm 1 increases their output in order to maximize their profits, knowing how firm 2 will respond, the decrease in firm 2's output is at a slower rate than the increase in firm 1's output, which we can actually see right here, right? In that as Q1 increases, that will decrease the optimal Q2 by 1/2 of the increase in Q1. All right, one last comment is the question that may be occurring to you right now, right? Which is, how is this optimal? How is this profit maximizing for firm 1 if in the Cournot outcome they didn't want to produce so much, right? If that was their best response to this, all right? Yeah, if the best response to this is to choose the same output, why, when they move first, do they choose that and this firm chooses a lower output? And the answer, the answer is even this, right, is not actually the best response to that, right? If firm 1 could now choose a different level of output, they would actually choose a different level of output. You took this best response, which still applies to a simultaneous choice, right? Or if you just took this level of output and stuck it into the original profit function and maximized firm 1's profit, you would find that they actually want to produce even more than this. Wait, no. They would want to produce a little less than that. But this is their choice, knowing exactly how it's going to impact the later choice of the follower firm, right? So it is not the best response were firm 1 able to alter their choice now, but that's because if they were to alter their choice, right, then it would alter this firm's best response choice. This is already compensating for, this is predicting the future choice of firm 2 and how they know their output is directly impacting that output. So best response doesn't fit in the same way when we're thinking about this sequential game, because firm 1 is not responding to this. Firm 2 is responding to that. Okay. And that's the Stackelberg model. We will stick with only really dealing with this with the constant marginal cost, just because we're limited on time in this course and don't have the space to do more with that. All right, thank you all for being here. This is me signing off. See you next. Well, see you at the final exam.